Hello. Video 3, coast topic. What is this lesson about then? Well, today we're going to look at how vegetation stabilises different coastlines, but in particular we're going to be looking at coastal plain environments such as sandy coastlines and then estuarine coastlines, alright? But for the most part, we're not thinking about rocky or cliffed coasts. We're thinking about flat, gently sloping coasts that slope gently towards the sea, have often deposition is the dominant process. So there's a supply of sediment, there's a supply of silt, clay, sands that are really soft, and somehow vegetation actually colonizes and stabilizes this sediment. And before we kick on, I just want you to think about what the word stabilize means, or where have you heard it. I mean, me personally, when I think of the word stabilize, it brings back memories of being 5 or 6 year old and my dad's teaching me how to ride my bike, and he puts stabilizers on my bike so I don't fall off head first and face plant and get grazed knees and elbows and what have you. So I guess if we apply that same line of thought or logic, then stabilise means the vegetation is somehow making the coastline less vulnerable. Alright? So just how I was made less vulnerable to falling off my bike and getting a pulley or two, vegetation stabilise coastlines from risks or threats, if you like. So, think about what those might be. Could be erosion, for instance. It could be energy spikes from storms. So plants can protect very vulnerable depositional landforms, alright, from erosion. We're going to have a look at a few of them. So, if we'll just have a look at the spec. We've nearly finished Key Area 1, folks, of course, which is good going at this stage. But we're going to look at cliff profiles, more detail in lessons. This is just going to finish off Key Area 1. Vegetation is important in stabilising sandy coastlines through sand dunes and saltmarsh in estuarine or estuary environments. We're also going to have a quick look at the role of mangroves as well, which we find in tropical warmer seas. Alright, give it a title then, nice new shiny piece of lined paper. How does vegetation stabilise sandy and estuarine coastlines? Alright, and then we're ready to rock and roll. Right then, we're going to kick off with sand dunes. Now, sand dunes, I've put together 3 photographs on the slide. Let me just line this back up because that is so annoying. Oh my days. Right, so sand dune ecosystems stabilise low energy sandy coastlines, hence the name, I guess, where it comes from. So sand dunes stabilise sandy coastlines. Coastal plains, it's, the relief is going to be flat, gently sloped towards the sea. And another point is, in the first photograph here, we see sand dunes just further inland from the back shore. Yeah. So it can stabilise just normal kind of coastal plain coastlines, but they also have a key role in stabilising low-lying depositional landforms. So I've pulled a couple on these 2 photographs. This is Sperm Point at the mouth of the Humber estuary, and you can see, this is a hooked spit. So deposition is the dominant process. It's created this landform through accretion. Yep, accretion of sand, and then you can see in the centre sand dunes have actually colonised and are kind of living there. So if you just think about how vulnerable this landform would be if it was just sand and it wasn't for vegetation. You can probably imagine how vegetation kind of can prevent or reduce the impact of erosion or storms, yeah, temporarily, but they still are vulnerable. And in this example, I think that's the mainland. This is an offshore island, and you've got a tombolo, which is a land bridge, low-lying depositional landform, which has again been stabilised by dunes. All right. Low energy environments, deposition is the dominant process, and then your vegetation grows on top of the depositional landform. All right. Normally, your supply of sediment will come from onshore winds, which are blowing, surprise, surprise, onshore this way. All right, so there's a supply of sediment constantly into these environments, or longshore drift. So tombolos and spits, for instance, are formed by supply of sediment drifting along a drift-aligned coast. Okie dokie. Right then, the next type of vegetation, which again stabilises coastal plains or elements of coastal plains, is saltmarsh. And saltmarsh we tend to find on the sides of estuaries, all right? And the reason for that is it's really good at kind of living in an environment where it's getting covered by tide twice a day. So salt marsh, like you can see in the photograph, stabilises estuarine environments, or as well river deltas. The vegetation tends to be submerged, so it'll be partially covered or completely covered at high tide, and then when the tide goes out, like you see in the photograph here, it's exposed. Also in the photograph, you see where my little cursor is, mud flats. Yep, deposition is still the dominant process, but rather it being sand, it's now mud or clay. All right. So once the tide and the river input deposit lots of mud, it builds up, and if you were to walk in there in your hunter wellies, it's probably gonna come over the top of them, and you're gonna get muddy feet. All right. Deposition again, and mud and clay is the dominant process. We get mud flats, and then the salt marsh grows on top of that. Yeah. What else can I say? Key word I'm going to introduce you to is flocculation, which is a type of deposition where it just means if you've got, like in the photograph, clay particles being deposited, they don't just settle and get deposited individually, but they actually stick together and bind together. And I'm not going to get too much into the science about it. Just imagine thick, gloopy mud. Yep. And the third one, if you've ever watched any Bear Grylls where he kind of jumps out of a helicopter in shallow offshore areas in the sea and then swims inland, it probably, first thing he comes across with his big machete and his water bottle is mangrove forests, all right? And these are more like trees, I guess. Sand dunes and salt marsh are more kind of low height, probably more vulnerable to erosion than mangrove forests. Mangrove forests, it's kind of a tree that can live in shallow tropical oceans near the coast. And I've popped a little map. The types of places where we find mangrove forests: coastlines of Central Africa, huge amount in kind of Southeast Asia, Indonesia, Northern Australia, Papua New Guinea, what a place that is, Thailand, Vietnam, Cambodia, Caribbean, for instance. So really warm places in tropical areas near the equator. More like a tree, got a complex root system, you can see here. They're really effective at absorbing wave energy from storms, cyclones and tsunamis. And often these mangrove forests can be, kilometres and miles stretching inland. So if you imagine the amount of energy they can absorb from cyclones, tsunamis, storms, they're really useful it's kind of a free buffer against coastal erosion and flooding. All right, and we don't have to pay for it either. We don't have to build seawalls. We can just use mangrove forests. That's if we don't cut them down like silly people do. Okay, then what have we learned? Well, we've learned that coastal plain environments, depositional landforms, need a constant supply of sand or mud or clay, and vegetation somehow makes the risk of erosion, flooding a lot less likely. All right, and we're going to start looking at the process. Well, how does this happen? All right, what are the processes? What enable this vegetation to live there? Yeah, and there's a couple of keywords that I'm going to introduce you to. So one is just in the question: how are pioneer species specially adapted to survive in harsh conditions? So a pioneer species is one of the first species that can colonize, in this example that you're looking at, your depositional landforms or your sand. Yeah. So sand is not very good. It doesn't really make very good soils. All right. If you planted, for instance, we'll look at an extreme. If you planted a tree on the beach, just think to yourself, would it grow? Yes or no? And if you said yes, then you're wrong. If you planted a tree on the beach, it would die. All right. And why would it die? Well, it's for vegetation. A sandy beach is kind of really harsh. Yeah. The water table is high, so there's not much fresh water. It's windy and exposed, but more than that, there's a lot of salt water. All right, and plants, if you water plants with salt water, they will die. Most plants will. So pioneer species are the first species that can colonize, in this case, a beach. Yeah, and a couple of examples are sea couch and marram grass for sand dunes. And in lesson, we're going to look in detail how they've adapted to live in sand, basically. Couple of keywords which we need to understand what they mean, and everybody always gets these mixed up, so if I say it again, maybe it won't happen. So can you think of a way of not getting these two terms muddled up? Halophyte plants. A halophyte plant just means it's a plant that can tolerate salt water. That can be either in the air or in their roots. All right, so they can tolerate being submerged at high tide or having salt spray kind of being kicked up by the sea. So halophytic plants or halophyte plants can tolerate salty conditions. Xerophytic plants or xerophytes can tolerate very dry conditions. All right. So if you look at that sand in the photograph, it's not gonna retain it's not going to retain much fresh water. Yeah, really salty, really dry conditions, and that's one way that these plants are actually adapted to be able to live on the back shore of a beach. All right, so this is kind of sand dune vegetation, pioneer species for sand dune. On the next slide, we're going to look at pioneer species for salt marsh. Right, folks, so in an estuary, or you'll hear me refer to it quite often as an estuarine environment, still the same logic really. We still need really specialised plants. And I've put photographs of 3 on here. So blue-green algae is the first one. Really specially adapted, can live underwater constantly if you like. Grasswort and cordgrass. Now these can't live completely submerged the whole amount of the time. All right. So if the tide covers them for certain periods of the day, they can kind of deal with that, but they can't deal with being submerged constantly. All right. And grasswort and cordgrass, the roots tend to kind of stabilise the mud. All right, and that means that there's more accretion. So it's kind of like a positive multiplier effect, if you like. Plants, specially adapted plants, stabilise the mud, bind clay particles together. You've got flocculation happening at the same time. The layer of mud flat gets thicker, and yeah. So again, all these three plants are halophytic and xerophytic. Okay, folks, next learning objective is kind of understanding what plant succession is. All right, and this is a sand dune succession, which, another key word, we call a samosphere. That's a silent P. So samosphere. And you don't just get one kind of plant just living on the beach and we get sand dunes. It's a series of stages. All right. So where the backshore is and the sea meets the land, then gradually as we move inland, we get different vegetation being able to kind of live as you go further inland. All right, so this is a cross section of the different kind of stages, and this is as well. It's showing the same thing really. It's just how I've done it. So if we think of the sea being at the left hand side, then again we've got pioneer species like sea couch and then marram grass that can xerophytic, xerophytes and halophytes. They can especially adapted to live in salty and dry conditions without much fresh water. And then, but gradually something changes because we end up eventually with gorse, bracken, and even pine trees. Yep, and this is actually a succession from left to right. All right, and the reason why this is possible is because vegetation changes the environment gradually. So other types of vegetation can grow. Yeah? And then those plant species change the environment again and allow different species of vegetation to grow. And this is gradual. Yeah? And eventually the environment, the soils, the pH balance of the soils, the amount of fresh water available, the sheltered conditions from the wind and the sea, it gradually changes until oaks and pines and birch trees are quite happy living in that environment. So the definition of plant succession is the changing structure of a plant community over time as an area of what was once bare sediment or sand is colonised by plants. Alright, so marram grass can tolerate salty, dry conditions. They then, by growing, change somehow, we're going to look at that in lesson, change the environmental conditions to allow red fescue, sea spurge, herbs and heather to grow. And by those being present and growing there, they then change the environment and bracken can grow, and this carries on until you end up with your climax community, which in the case of sand dune succession is oak, pine and birch. Alright, so a samosphere is a sand dune succession from pioneer species near the sea to oak woodland inland. A halosphere is a plant succession for a saltmarsh ecosystem. All right, it's same theory, same logic, just different vegetation or different plant species, really. And again, there's the influence of the tide to think about as well. So, if we think about the part of the estuary shore which is permanently submerged, yep, Only really specialised plants can live there, such as like your algae and possibly your sea lettuce. Yep, they colonise the mudflat. And yeah, it just says here, colonisers have nearly permanently submerged mudflat where tidal water is clear enough to let light levels through. So they still need some light, but they can live being submerged. They help stabilise and bind together the mud. Because they do that, the next set of species, these have adapted the conditions, so the next set of species can live there as well, and they have a different role. So they trap sediment and tidal waters, and that's where your cordgrass and your glasswort come in. And these are also highly adapted, but they can only be exposed for 4 hours a day. All right, they change the conditions, and then you get more different grass species which can grow as you move inland. Eventually, again, your natural climax vegetation would be a woodland. Yeah, so really specialised plants on the banks of the estuary that are submerged most of the time, like algae. Change the conditions gradually, and different species can then grow as you come inland. Alright, and that's about it for today, folks. It's a vegetation stabilising halophyte, xerophyte, pioneer species. Yeah, kind of day today. So bring your notes to the lesson on Thursday with me. Have a good one.